Okay, so we've got a picture of a graph with two straight lines on it, L1 and L2. It gives us the equation of L1, and the first thing we've got to do is just work out or state the gradient of L1. Well, it gives us the equation like this. Now, to find the gradient, we need to put it in the form y equals mx plus c, and then the coefficient of x will be the same as the gradient. So if we divide through by 4, and 12 divided by 4 is 3, that's an equivalent equation of the straight line, and you can see from that that the gradient of L1 equals 5 over 4. Done. Part B. The line L2 is parallel to L1, and it goes through the point 12, 5. Find the equation of L2. So, well, we know that because it's parallel, the gradient of L2 will also be equal to 5 over 4. But we also know it goes through the point 12, 5. So the best way to do it is, you can do y equals mx plus c, put your value of y and x in and work out what c is, that's fine. Or it's sometimes quicker just to do it using this method, y minus 5 equals 5 over 4 x minus 12. Now we want it in the form y equals mx plus c, so we're going to have to multiply out the brackets on the right and add 5 to both sides. So y equals 5 quarters x minus 12 5s 60 over 4, and then plus 5 equals 5 over 4 x, and then that's 15, so minus 15 plus 5 is the same as minus 10, and that's the equation of line L2. Right, now the line L2 cuts the x-axis at the point C, and it shows us the point C is here. Okay, and it tells us that it cuts the x-axis at the point C, and it cuts the y-axis at the point B. And we've got to find the coordinates of those 2 points. So, part C, 1, the point B. Well, we know the equation y equals 5 over 4x minus 10. Now, at the point B, you know that the x value is 0. So if we put 0 into the equation, you can see that y is going to just equal minus 10, which tells us that the point B is the point 0 minus 10. And part 2, the point C, well, at the point C, we've got the same equation, it's the same line we're talking about, 5 over 4x minus 10. But at C, we know that y equals 0. So if y equals 0, we're going to have 5 over 4x must equal 10, which means that x equals 40 over 5, which is 8. So we know the point C is the point 8, 0. Okay. Now, the final part. The line L1 cuts the y-axis at the point A. Okay, and it shows us that. So, and then it says that the point D lies on L1 such that ABCD is a parallelogram, as shown in figure 2. And then we've got to find the area of the parallelogram. So what we're trying to do we're trying to find this area here. Okay, now we know from part C what points B and C are, so if I just move down, B is the point 0 minus 10, so I'll write that on there. B, that there is 0 minus 10, and we know that C was the point 8, 0. I think, yes, C is the point 8, 0. Now what about point A? I think it's going to be useful if we work out what point A is. Well, point A is the value, the y value at point A is going to be the value of y when the equation for line A has x equals 0. And if you put x equals 0 into the equation for A, you just get y equals 3. So we know that that point there is the point 0, 3. Okay. Now how do we find the equation of a parallelogram? Well, if we call that length from A to B, if we call that the base, we know that's going to have a length of 3, basically 3 add on 10. So that's going to have a length of 13 units. And to find the area of the parallelogram, what we have to do is multiply the base by the perpendicular height. Now the perpendicular height is just the length from 0 to C. Well, is the length from the origin to C. Well, at the origin the x value is 0. At point C the x value is 8. That means that this length here is 8 units. So for part D, the area of ABCD is just going to be the area of the base, which is 13, times the perpendicular height, which is 8. And 13 times 8 is 104, and I could call it units squared because it doesn't really tell us what the units are, they're just numbers. And there we have it.